Today is our first lecture of mathematics second year. These are the course contents of your book. Today we discuss the first chapter, that is about functions and limits. This is the pattern of your paper. In second year, your paper is your paper has three sections: section A, section B, and section C. In section A, you have 20 MCQs, and each MCQ carry 1 mark. In section B, you have to attempt 10 questions, 10 short questions out of 14. And in section C, it's a long section in which you have to attempt 5 questions out of 7 questions. Now we start our chapter. First, I will give you the intro of this chapter, concept of function, definition of function, domain range concept, real valued function, dependent and independent variables, graphs of function, and types of function. Basically, functions are important tools by which we describe the real world in mathematical terms. They are used to explain the relationship between variable quantities, and that's why it plays a central role in the study of calculus. Here we have an example to explain the concept of function. This is the example about the area of a square which depend on its sides x. Look at the formula. A is equals to x square. In this formula, you can see you give the values, you give the different values to this x, and these different values generate different values for area A. You can see the table. When you give the value 2 to this x, A will be 4. When the value of x is 4, area will become 16. Then value of x is 5, area become 25, and so on. It means we can say that x is independent variable. It's up to your choice that you suggest the value of x, but A depends on the value of x. So x is independent variable and A is dependent variable. Or in simple words, we can say that A is a function of x. Here we have another example. This example is about volume of a sphere which depends on its radius. If you see the formula, V is equals to 4 by 3 pi r cube. In this equation, 4 by 3 pi is a constant quantity. So we can't change the value 4 by 3 pi, but it's up to our choice that we give different values to this radius r. Here I have given r is equals to 1. So volume becomes 4.18. When I give the value 2, volume become 33.49. And same is the case with these this another value. So we can say that V is the function of R. Means or volume depends on its radius. These are the 4 ways to explain the relationship between variable quantities. We are very familiar with this type of representation of two sets. This representation is called ordered pairs. These are ordered pairs of set A and set B. The first term of all these ordered pair represents the set A, or we can say 0, 1, 2 and 3 are the elements of set A. And the second elements of these ordered pairs, which are 2, 3, 4 and 5, these are the elements of set B, right? Now, when we apply these ordered pairs on a graph paper, we get a graph of this relationship. And this is the second representation of this relation. This is the third type of relationship. The values are same, the quantities are same, the sets are same, but these are four different ways to express the relation. This is the table method used to show the relation, and the last one, mapping. In mapping, you can observe that the first set, which we called A, is a domain or input of the relation, and the set B, which is known as range of the range of mapping, are the outputs of the mapping. Now function, which is the main topic of our lecture. First, I will read the definition. Let X and Y are two non-empty sets. Then a function f from set X to a set Y is a rule that assign to each element X in capital X to a unique element Y in capital Y. And we can write this relation like f double colon from X to Y and read it as function f from set X to set Y. In simple words, we can say that function is such a computing machine in which we input some x and we get exactly one output, and that is f of x. Here we have a simple example. F of x is equals to 3x plus 1, right? And here we have given different values to x which generate different corresponding values for f of x. This is also describe the relationship between input and output. When we take different variable x, t, theta, and we make the relationship with function, so we write it f of x, g of theta, h of t, and so on. When we input our domain, we get range or image as a output. When we input domain element, we get range element. When we input independent variable, we get out as a output dependent variable. When we input argument, we get as the output value of the function. So these are different terms which we can use for input and output. Now, this is the very important and very simple example to explain the concept of function. The first one is the old way in which we say what is y is equals to 2x when x is equals to 5. Means at a specific value of x, how this equation behaves. Solution: y is equals to 2 or 5 is equals to 10. You can understand this concept very easily, but comes to the new way in which we use functions notation instead of this simple algebraic expressions. In this function notation, we say f of x is equals to 2x is given and we have to find the function's value at point 5. So what we do? We just replace x with this value 5. So f of 5 is equals to 2 multiplied by 5 and gives the same result, that is 10. So we say that 5 is the input and 10 is the output. Now in this slide, two types of relationship is given. In relation 1 is a function and relation 2 is not a function. But what's the reason? The reason is, you can see in relation number 1 we have three elements in domain, and these are 1, 5 and 8, and two elements are in range, and these are A and B. And when we start mapping, you can see the domain element are uniquely mapped with range element, and 1 is mapped with B and 8 is also mapped with B. There is a repetition in range element, but domain elements are not repeatedly used. But in relation number 2, that's why we say that relation number 1 is a function. But in relation number 2, in which I have written that it's not a function. The reason is, look at the domain element. Domain elements are not uniquely mapped with the range element. If you see the 5, which is at a time mapped with A and C, that's why we called it's not a function. This relation is not a function. Here we have another example of function and not a function. You can see the first table in which domain elements, which is represented by x. You can see the column of x 1, 2, 3, 4, 5 and 6, and they are uniquely mapped with elements of y, and there is no repetition in domain element. But in second case, you can see 1 is mapped with 2, and again at third row 1 is again mapped with 5. So in this case, the given relation is not a function. Now, test of a function. This is another way to test whether the graph of the relation is a function or not. It is a vertical line intersect a graph in more than one point. It is not a graph of functions. In simple way, you can see the first graph in which the red line show these black lines show the x-axis and y-axis, and the red line represent the graph of the graph of function, and yellow lines are the test lines. They intersect the function vertically, and you can see easily these yellow line intersects the red line at one point. That's why we called it a function. But in second graph, you can see the vertical line yellow is intersect the graph at two different points. That's why this graph is not a function. Same is the case with third graph. The vertical line intersects the red line at two different points. That's why this is also not a function. But in this fourth graph, you can see the line intersects the graph at one point. So that's why it's a function. Again, it's not a function. And the last one, it also shows it's a function. Now, types of function. We have different type of function, and we will discuss all these functions one by one. We have algebraic function, and algebraic functions divided into five main functions: polynomial function, linear, identity, constant, rational function, while trigonometric and inverse of trigonometric functions, and then hyperbolic and inverse of hyperbolic, exponential function, logarithmic function, explicit, implicit, even, odd, and piecewise function. The very important type of function is a polynomial function, and the polynomial function are those functions in which the largest exponent within the polynomial determines the degree of polynomials. What I mean to say, look at the first expression where y is equals to ax plus b. In this expression, the highest power of x is 1. That's why we called it degree 1 polynomial or linear function. In second case, the highest power is 2. That's why it's the degree 2 polynomial and it's a quadratic function. Then highest power is 3. So it's a degree 3 polynomial and it is known as cubic equations. And the last one where we have the highest power of x is 4 and it's a degree 4 polynomial, and that's why we called it quartic function. But in all type of functions which are polynomials, in such functions we have the elements which we used as a domain are all real numbers. Means the domain of polynomial function is from minus infinity to plus infinity in open interval, and range is also real numbers. Example of polynomial function, f of x is equals to 3x plus 4, or you can write it like f, instead of f of x you can use y is equals to 3x plus 4. Both expressions are same. Now domain of these functions are real number and range of these function is also a real numbers. These are the graph of different functions. Constant function, no change in graph. Linear function is a straight line and degree 1 function. Quadratic function, whenever you solve a quadratic equation, you get two results at the same time because the degree of a polynomial suggests the root of your equation. If you are solving second degree of polynomial, means your roots will be 2, and if you are doing or you are simplifying the cubic function, a cubic equation, you have 3 roots. So that's why at the same point we have two different values, positive and negative, in our quadratic function. This is the cubic function, this is a quartic function, then a quantic function. Now constant function, when there is no change in a function, there is no variation in this function, this is called constant function, and we define it from c is a function from x to y defined by c of x is equals to a is a numeric value, and for all values of x we get the same result, and the result is a. Look at the example. Here we have c of x is equals to 2 from minus infinity to positive infinity, which is the domain of this function. You can put any value of x, as a domain, but you get the same result, that is 2. So that's why we can say domain of this constant function is a real number, but the range of this constant function is always a singleton set. Rational functions. All those functions which can be represented by a fraction of polynomial, means r of x is equals to p of x divided by q of x, where p of x and q of x both are polynomial functions, and with these polynomials we have one important point is that the q of x does not equal to 0 is called a rational functions. Here I mean to say q of x does not equals to 0 means all those points exclude from minus infinity to plus infinity, which gives 0 result in denominator. Look at the example 2x plus 1 divided by x. In this example, you can put any real number and just avoid which number? 0. Why? If we put 0 in this example, we get 2 multiplied by 0 plus 1 divided by 0, which gives you 1 divided by 0, and which is undefined form. So that's why we avoid those numbers in rational function which gives you 0 in denominator. So you can note domain of a rational number are the set of all real number for which q of x does not equals to 0. Trigonometric function. These are 6 different trigonometric functions: sine, cos, tan, cosecant, secant, and cotangent. And how we decide the range and domain of these functions. You have discussed all this concept in your previous class. So that's why you can easily understand this concept, how we say that the domain of this sine x is ranges from minus infinity to plus infinity, and its range is from -1 to 1, right? And here we have the different graphs. I would like to explain the concept of open interval and close interval, which these terms I have used many times in my lecture. Open interval are those interval where the endpoints are not included in your interval, and the closed interval are those intervals in which the ending point are included in your interval, right? Means in this interval 2 and 5 are not the part of this interval. In this interval, we just have all those numbers which are less than 2 and which are greater than 2 and less than 5. But in close interval, in this interval, we have those points which are started from 2 to and started from 2 and it ends at a point 5. Inverse trigonometric functions. There is a comparison of these two type of functions. These are simple trigonometric functions, and in this table we have inverse of trigonometric functions. And here I'm comparing their domain and range. You can see easily the domain of all these trigonometric functions becomes the range of their inverse function, and the range of these trigonometric functions become the domain of their inverse function. Exponential function, all those functions which can be represented like f of x is equals to a power x, where a is a positive constant, a does not equals to 1, and x is any real number, is called the exponential function of base a. Base a means you have a power of any constant number. Look at the example. Graph the exponential function given by f of x is equals to 3 power x. Here you have 3 as a base and x as a power. So you give different values to your x, you generate different corresponding values of f of x. This is the table and this is the graph of this table. Explicit functions and implicit functions. Explicit functions are those functions which are easily in which we can separate the variables easily. You can see at left hand side you have y, and at right hand side you have those terms which uh, wi- uh, uh, um, those terms which contain x. And in implicit function we have those equation which does not separate easily. Look at the example, y5 minus 3 x square y square plus 2 is equals to 0. In this equation you cannot separate the variable uh, to to opposite sides. So that's why these functions are implicit function in which we cannot separate the variables, and explicit functions are those functions in which we can separate the variables easily. Even and odd function, all those functions which can be expressed like this, means f of minus x is equals to positive f of x. This type of function is known as even functions. Or we say that in this type of function, the function digests this negative sign. F of minus x is equals to positive f of x. So it's an even function. But in another case, when f of minus x is equals to minus f of x, such type of function is known as odd function. And you can see the example. f of x is equals to 3x square plus 8, and when you replace this x by minus x, you get this result, and which is equals to f of x. That's why we called it even function, because f of minus x becomes equal to f of x. But in another case, when f of minus x is equals to minus of x, so this function is odd. And the last one, in which f of minus x does not equals to f of x, and also it's not equals to minus f of x. So we say that this function is neither even nor odd function. Piecewise function. What is a piecewise function? A function that combines pieces of different equation. You can see the example where we have two different type of equations. Minus x plus 2 is one equation, and 3x minus 3 is our second equation. And you can see that f of x is equals to minus x plus 2 if x is less than 0. This x is less than 0 describe the domain of this expression. Means your domain ranges from minus infinity to less than 0 in open interval. But in second case, where we have 3x minus 3, if x is greater than 0, x is greater than 0 means you have a domain for this expression started from greater than 0 to plus infinity. So we can say that a function that combines pieces of different equation, each piece is for a different domain, right? This is a very useful link, and you must watch this video to understand concept of function. Thank you.